In this video, we're going to practice problems related to a vehicle turning on a banked curve. This problem explores how the banking angle and friction allow a car to safely navigate a turn. To handle these problems, we generally need to understand two different scenarios. In the first scenario, imagine the vehicle is traveling at a low speed, or maybe the bank surface is slick. In this situation, the car tends to slip down the bank, right? So in this case, you'll be finding the conditions needed to prevent that downward slide. Conversely, think about vehicle moving way too fast or at a very high speed. In this scenario, the car tends to fly away from the bank or attempt to slide up the bank. Consequently, here you will be looking for the conditions that stop the car from flying off the road. So to begin our analysis, we always start with the free body diagram. To work on the free body diagram, both scenarios start the same. The car always experiences the gravitational force Fg acting downward, the normal force Fn acting perpendicular to the road surface, right? But the big difference comes down to the friction force. We know that the friction always opposes the tendency of motion, right? If the car tends to slip down, friction points up, right? So this is the case when the car drives at low speed, the friction should point up the bank. But if the car tends to slide up or fly away, the friction should point down the bank. You might be wondering, how do you define the high speed or low speed scenarios? Well, essentially the first step is actually to figure out the speed considering a bank curve whose surface is frictionless. And this value acts as the reference point. Please check out the full video for an example.